think the mic works. I can hear a little bit of echo, so I also have a loud voice, so if I start getting excited and yell too much, let me know, please. Okay, I think I'm going to get started. We're right on time, just 1 minute over and all that. I was expecting much less people after lunch, so I'm going to be trying to be very entertaining and keep you awake, because it's a tough time. First thing that can keep you awake is my name. It's really long. You can gain many vowels through that, so it's a Greek name. But I have a cool nickname that you may remember, actually. So my name is Xenia, Mountrouidou, and you can call me Dr. X or Xenia or Xenia or something like that. I'm a senior security researcher at CyberAdapt, a startup, and my research intersects within the areas of machine learning and cybersecurity. So before private industry, so I was, before CyberAdapt, I was in another private company, and before that, I gave 10 years to academia. So I like teaching. I really love sharing these kinds of things, so I hope you can learn. I have more research interests than these, but I put the basics over here. I love building stuff. I also built a website. I have my blogs over there, and there will be more related blogs. I have a whole series related to this talk. So if you want to learn more, again, I'm very happy to share. Yeah, I'm happy to share code also, so because I learn by doing. Okay, I have more hobbies than I have free time. So I always put that cool picture. I take crappy pictures underwater, but this is a cool picture that a friend of mine took cave diving. Of course, it doesn't look like me. And I also love reading, playing the piano poorly, and comics. Okay, so let's get to the talk. Today I'm going to talk to you about ML and AI for cybersecurity. I had a pretty provocative start in my abstract that said I believe the next generation cybersecurity engineer is going to be a data engineer that happens to specialize in cybersecurity. I think that it's going to be a cool combination. If this talk inspires you to get further into data, that's really cool. I think you're going to find a whole new world of cool things, discoveries, creativity, and all that. So I will give you the what of the day-to-day of, yes, sometimes I call myself a data scientist, but I do specialize in network security, so I understand protocols, I even understand operating systems and things like that. So I will give you the nitty-gritty details of the what, and I will do it in 2 ways. So that's really exciting for this talk, because I will do it the traditional way, but I will insist a little bit on the new tools that we have right now that are almost zero coding tools, so you can interrogate your data with the AI way. I will say, though, and that meme has gone around, and I'm not big on social media. I had to Google a lot to find it. But that is the story of my life right now. So when I was doing my PhD, it was really called statistics, and I had 5 people in the room when I was giving talks, and they were all falling asleep. And then we called it machine learning, and that was pretty good. So I had 10 people in the room, and now it's called AI. And it's not the same thing, okay? So there is a strict definition. I used to be in academia. AI, machine learning, is a subset of artificial intelligence. You both have heard of it. So what would you think is the big difference between artificial intelligence and machine learning? What would you say is the big difference? Have you ever wondered? I mean, they're not the same thing. Has anybody wondered? Say it again? The data sets. Well, if you Google it, you'll see it's not just a data set. It could be, I mean, the big thing with AI is it can act as an independent agent. Okay, I don't think we're there yet. We're getting there. I mean, the models are learning from us, but we're still training models, okay? The GPT, how many of you have used ChatGPT? Of course, Probably all of you, good. They're gathering data on all of us. So the GPT is still a trained model. And yes, the data set was huge. So they paid a few million to train that. So it is like an AI, but is it really? And it can make silly mistakes, okay? So it's not an independent agent. There's an AI scientist, and I don't call myself an AI researcher because these people are trying to truly make an independent agent that gets into a room. Let's say a robot gets into a room, and there's so much stimuli, and they don't freak out. They don't get crazy. They don't feel completely threatened or anything like that. So as humans, we have this ability. They don't yet, so I'm careful with what I say about our AI overlords because, I need to be on their good side. Okay, so there are differences. ML is us teaching machines with smaller data sets also, so I'm going to be using a smaller data set. I'm going to be doing the machine learning cycle for a cybersecurity person, and I'm offering this code free and open, and please feel free to scrutinize it. I won't say that is a performance-oriented data science code. It was created for a demo to have small chunks that I can show you what to run and give some understanding. So if you want, you can clone that repo and follow. Half of my talk is going to be that demo, actually, and please, if you run it and you have trouble running it, please contact me. I'll have my contact at the end of the talk. Okay, so why do I think that? Okay, so how many of you handle data day to day and see, tons of graphs in front of you, or, you gotta have some data, right? SOC analysts, I mean, you're looking at these screens full of data. So why ML and AI are going to be a match made in heaven and are a match made in heaven for cyber. So I do intrusion detection research. So marrying the deterministic ways of finding an incident is really nice with machine learning. So I have my models, and next to them there may be rules, and they can enhance each other. They can give some confidence to each other. So there's also faster response times, not only in finding something, but think about, when you're in panic mode, when an incident is happening, you have fed an AI, a language model, with all your processes, all your manuals, and it can really quickly answer what you need. So the response time and the quality of responses is going to be bigger. Automating the boring things, I mean, I cannot say how much I have suffered with boring tasks in cybersecurity, and these models can help us. They can do this boring stuff for us. And of course, being more adaptive, because we don't know what we don't know, and these models can recognize patterns. So all of this stuff is great. I'm a comics person, so I'm going to have a lot of pictures. What I have over here is the ML ops, the ML operations cycle that starts from the raw data, and it can apply so well. I mean, many of you are in the raw data. Maybe you have your Splunk or Elastic looking at your beautiful graphs. You curate the data and retrieve it and look at it in pretty graphs. You could go through the next of the steps of modeling and all of these fun things. So I really think that all of you can do this afterwards, especially with what the GPT models are giving us right now. Okay, so I'm going to go through all of these in detail in the next few slides and with a demo. Okay, so first, what data do we have in security? And of course, we're storing it in fast retrieving databases. How many of you use Elastic? I've seen a booth also that has Elastic out there. Oh, few, but yeah, I thought, okay, a good chunk. So the data is going to be the first. That EDA, okay, I like abbreviations. It's exploratory data analysis. So really, this is what we spend most of our time on exploring. So data science people, we spend most of our time exploring this data as a black box, okay? So we get these packet captures. I get tons of packet captures in my day-to-day and explore them as a black box. I don't know what they're hiding, but they could have a very interesting story. And the second part that we spend tons of time, so you could say 40-40% is the feature engineering. So picking the characteristics of the data that can tell us a good story and tell the C-level execs a cool story, making a product or, doing some cool other things. But the least amount of time we spend on modeling, and it's the most glorious thing at the end, okay? Models can figure out whether something is malware or not, or models can figure out, can forecast whether there's going to be the next big outage or something like that. And yet, even though it's the most glorious part, it's the part that we spend the least amount of time. So my day-to-day is mostly, I'm focusing on Internet of Things. So my day-to-day is trying to get data from these devices. I get packet captures and all that. But of course, many of you would be getting logs. I don't get that much logs, but this is, the sources can be the network, the systems, logs usually, and of course malware. And there could be more, actually. So you could give me some ideas of some things that I'm overlooking here. But these are the three sources that I have used mainly. And then the types of data, okay, packet captures from the network, from malware, binaries. So there's been interesting analysis of binaries with pictures and how we can transform it to a picture and recognize malicious versus non-malicious. Static dynamic analysis. And then there's some things that we don't think, like, passwords. So there's a few passwords lists out there that could give a data scientist some insight of how people pick passwords and how to help them not pick these common passwords, so in a more educated way. So these are data sources that maybe you never think about, or, I've been doing a lot of focus on domains because I do research on DGAs. So, there's tons of open source stuff over there, or algorithms to create algorithmically generated domains. So there's a wealth of data that we have as security people, so it truly makes sense to use the data science tools, the machine learning and AI tools. So feel free to interrupt if you have a question and all that, and I'll keep going with the slides. So the next, let's get to the steps now. Okay, so we have our data. We have some good people also gathering data for us. And now we're looking at it and we're like, what the heck? So usually we go to some pretty pictures. Okay, like I said, I'm a comics person and I'm pretty visual. So there's tons of ways to visualize data for different reasons, right? So we can visualize data to understand how they spread in a two-dimensional axis, like that's a histogram. But we can visualize data with that violin plot to see correlations between features, between the columns in your spreadsheet or something like that. So, and all of these ways, you don't have to be a programming wizard. So I have some one-liners that you can use to make these graphs. Thank you, Python. And now there's also prompting that you can do to create those graphs. So I'm going to show that in my demo. And then after the pretty pictures, okay, there will be math. Sorry. It happens. So it's called data science. So data science is mostly mathematicians that were not very good in theory and they wanted to do more applied stuff. So there will be math. The math, though, again, you can approach it as aggregating statistics. That can be some, again, really cool numbers that can give you some really good information on how your data relates. So how does a source port relate to a source IP? because you have different behavior inside the network and different behavior outside the network if it's external IPs. So these, the statistics, the correlations can give you that. So exploratory data analysis also will not just give you numbers, it will also help you test some hypotheses, which is really cool. So how statistically significant is the relation of the total number of packets in my streams compared to the duration of the streams? Of course, there has to be some sort of statistical correlation between those two. So lastly, Hacking Dave yesterday, I don't know if you were, how many of you were at the Security Onion conference? So a good chunk of you. So Hacking Dave was talking about that long tail and the values that are rare. So we have a lot of noise. If you're a SOC analyst, there's so much noise, so many false positives. But then there's a rare event. And again, exploratory data analysis statistics can help you find those rare events and see, wow, there's something going on that is out of the usual, and maybe it needs my attention. And that's, again, pure, straightforward tools that, thank you, data scientists and Python that did that for us. So now I'm going to the newer stuff. And I'm going to say, once you use my code, it may break because this is a moving target. So you can do exploratory data analysis with a new framework. So data science people use these pandas. Okay, they're not cute little bears, although I love the analogy. They are data structures that are really Excel spreadsheets. Two-dimensional arrays of your data, and what they do is they facilitate how we process our data. Okay, we have columns and rows. Life is good and neat. So there is a framework now that is combining these pandas with OpenAI. So that's what I'm going to demonstrate. And of course, you can also use your own models. That's a little bit more elaborate. So now you can do exploratory data analysis, statistics, graphs, without having to know all of these libraries that I had to learn, but it's just prompting GPT, as long as you're OK uploading that data over there. So there's this caveat. OK, so that's really cool, and it can help learn, but also it can be a quick solution. OK, so that was one of the parts that data scientists do a lot. Dora the Explorer, explore the data. The second part is feature analysis. So my demo is going to have a lot of these. So the feature engineering is not as, stardom as we think data scientists. It's mostly cleaning garbage. So first we start with a lot of garbage. So lots of duplicates, lots of missing values, and we have ways of removing those. It used to be that I had to write elaborate code. Now I can do it with prompts. So after we curate our data, okay, which can be painful, then we have to extract features, and then there's mathematical ways. The principal component analysis is one that is used a lot. And there's also domain knowledge. That's where it comes handy to be a cybersecurity engineer, because you can understand source IP, destination IP, protocol, services, port services, and all of these good things. So domain knowledge is the part of, it's not science, it's art. And the data scientists may not have it, but you guys have it, you're specializing on this. And then you have the holy grail of your data science. If your features are good, the features that you produce, then life is good. Your models are going to be pretty good. So there's two types of features over here. The upper part is categorical. The lower part is numerical. So categorical is what language models deal with. Okay, they're words. Okay, so all of these words, though, the language models, the AIs, they don't understand words. I hate to break it. I mean, you probably have seen it. There's a lot of analysis of how it works. It's not words it understands. It's numbers. Okay, so tokenization and converting these words to numbers, that's what it understands. And that's the brilliance, actually, of the AI that we are using right now, how we are doing these conversions of words to numbers and keep the context of words so that these models are smart, like artificial intelligence. And then there's the numerical data that GPT is not very good at. So I'm going to show in my demo that, unfortunately, I can't do my models with GPT with numerical data. But it's really good for the data scientist to convert, to get their numerical data. And again, massage it a little bit, because IPs, yes, they're numbers, but they're not just a single number for the model. So we have ways on converting IPs, for example, to numbers, keeping the context of, being in the same subnet and things like that. So yes, numerical and categorical data. So again, the sources that I have, and I will be posting my slides on the same Git repository. I just wanted to wait until the conference. And the sources are really good. So I have a daily dose of data science over here. If you want to start your journey with data science, I love intuitive explanations with not too much math and pretty pictures. So this is showing actually how we do this categorical encoding. The top shows a really cool way. So let's think about an example from networks. TCP, UDP, HTTP, MQTT, for example. This could be 4 protocols that I have in my packet capture, and I can do one hot encoding, which looks like binary. It takes a little memory, but it's really efficient. So I really like one hot encoding. It has saved my life a few times. So it's simple. It takes some memory, but it's a good translation of categorical data. And then there's other types of feature engineering for that. But then, yes, we transform our words to numbers, but we also need to pick the most important features from our data. So if you've looked at the packet capture, there's tons of fields, okay? If you get the whole OSI, okay, MAC addresses, IP addresses, blah, 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 blah. I don't want all of that, okay? I don't have OpenAI's budget to train a model for days and pay AWS hundreds of dollars. Or thousands, actually. So I want to extract these features with some cool math. Principal component analysis is one of the cool methods. It takes the data and it says, okay, this is the data that is the most interesting because it causes the most variance. So, IPs, let's say, and ports is the most interesting in a specific packet capture, or packet sizes and all that. And it could be 2 features from all your data set, or 3, or I have a model now that I thought it would be 30 features, but it's 6, actually. So, and it's all about variance, okay? So if I pull this feature out, does it still change? Is it still interesting? Think about variance as something like that. So, and then after all this math and all these things we had to learn for data science, we have Pandas AI doing this for us. It has a function to prompt GPT to generate features. I will say that I would welcome you, if you're into Python, to contribute to this project, because I think that they can get some help. This prompt is a little simple, but they've done a fantastic job, okay? I'm not bagging on them. I'm using the framework, the libraries a ton. But, this is a simple prompt, and you will see in my demo that it doesn't generate very interesting features. But still, with the prompt, you can generate features and tell a story. Okay, finally, the 20% of the data scientists' work, which is also the most impressive one. The C-level people are like, yeah, models. And we're like, no, I spent all my time exploring the data and feature engineering. But oh, well, yeah, models. So models, there's tons of them. Again, another resource that I strongly recommend, illustrated machine learning. See the pictures here. I have a thing for them. So the models are plenty out there. And you can split them with 3 criteria: supervision and parameterization and linearity. Okay, so supervision, let's take that because we all know GPT, okay, generative, pre-processor, pre-trained, whatever, what's the T for? Transformer models. Where does this model stand? Actually, it is more in the, believe it or not, what do you think? Is it a supervised model that we supervise it completely and tell it, you know, how to react to external stimuli with labeled data, like we tell it this is malware, this is not malware, and then we show it something unknown and it figures things out? Is it unsupervised? We just feed it a bunch of data and it figures out the patterns, or is it semi-supervised? So what do you think? Semi, exactly. So, and that's our life, right? So think about your life as a cybersecurity engineer. So semi-supervised means I have some malware samples that analysts have spent hours, and they have written cool blogs, and they have labeled them in a way for me, but there's only 100 because, you know, I can't work them 7 days per week, 24 hours per day. So there's only a few of those samples. But then I'm downloading all these samples from VirusTotal, Malware Bazaar, that they say it's malware, but I don't know, so they are unlabeled. So I use the work of pain from my analysts to help label other things or help train these semi-supervised models. So these are the ones that I resort to most of the time. I have a few labeled data and then unlabeled. And then there's parameters, so you can hypothesize about your data or not, and linearity, and that's about it. Okay, last 2 slides, and then we'll go to the demo. And try to run it while I'm doing it. So to run it, you will need an API key. So last 2 slides, how do we train that data? How do we teach the child to learn about the world? We have the data set. We split it in 3 parts: training, validation, and test. The biggest part, of course, is the training. It has to learn somehow. The smallest part is the validation and test. Validation is it valid? Is it finding the right things? And test is feed it something completely unknown and see if it can actually do it. And what I use in my demo, and what is de facto, actually, so you will have to use it if you do data science stuff, is the k-fold cross-validation, which is taking the data, split it in 5 different parts, and then take 4 parts for training and 1 part for validation, rinse, repeat 5 times with a different part for validation each and every time. Okay, so this is the way to do it so that you create unbiased models that haven't seen eventually all the data, but they don't overfeed their knowledge to your specific types of data. Okay, so and this one, again, is a good visual because I use this in my demo to evaluate the model. So we calculate a metric, let's say the accuracy or how good the model is in every iteration, and then we average it. Okay, so confusion matrix, I taught this in college. It's called confusion for a reason. True positives, false positives, you've seen them, especially if you're doing SOC and all that. We want to be in the diagonal of this matrix, okay? We want to have all true positives and all true negatives and nothing else. If only life was so ideal. So then we have other metrics in the data science realm that you can, again, calculate with single liners, actually. Accuracy, precision, and recall. Okay, and these are some good visuals. So the precision is the way that we see how many of our retrieved items, we take all the true positives, so our true relevant predictions, divided by true positives versus false positives. So how many of the items that were retrieved were relevant, or how many of the items that were, how many relevant items are retrieved. So I think it's a pretty good explanation. I mean, we can spend tons of time on evaluating models, but I want to get to the fun part. So I'm skimming through this a little bit. Finally, you know, large language models. They can do the modeling for us. They don't do the evaluation. I'm doing the evaluation over here. But still, it's not really bad, and they can give us some accuracy. So you see I have, from my actual demo, some accuracy results. GPT-3, a little less good than GPT-4. Actually, that is a little inconsistent. So without further delay, I'll go to the demo. First, I will say, if you went to that website, I'm using VS Code. So I call it the Cadillac of IDEs. It's really good. I mean, but you can use anything you like for this demo. You can use Colab, Google Colab. Then you don't have to set up an IDE. But I do have a whole tutorial if you want to use that. VS Code has pretty colors. So, you know, I have a weakness for pretty colors. So there's that. So I also use what day-to-day data scientists use, which is Jupyter Notebooks. This is literally running your Python in small little chunks, okay? Because there's lots of code over there, and I need to see results and see how I'm going to move on to the next part. They're really great for teaching. Also, so yes, strongly recommend to use those in any type or way you want. They're also great for documentation. So I can quickly go, so I have markdown documentation, and I can quickly go to the different parts of my code without any hinge. So let's start with this. I will walk you through the whole thing. We do have half an hour. I plan to do it in 20 minutes, and maybe I'll run a thing or two. I have sacrificed a couple of curls to the demo gods, but sometimes it doesn't work. That's why I can't get any longer hair. So, you know, anyway, silly jokes. Okay, so first, this is a pain for any data scientist. It's all those packages that we have to import, okay? So there are a lot of packages that we have to import. But if you just start using this framework, the Pandas AI, there's very few packages that you have to import. So if you hit play, you see that this has run, and happily it worked. The previous part is just installations of those packages, so I'm not going to drill too much with these. But again, if you have questions, if you are a beginner, shoot me a message, and I'll be happy to answer. So I've imported my packages. Now, your security people, so I hope everybody can see that. Back over there, you can see, right? It's big enough. Can make it bigger. OK, cool. So you're security people, so you don't want to expose your secrets in your code. So there's this one line of code in Python, load your .environment, and my .env is a file that I never check in Git, so nobody sees my secrets, okay? Been there, done that, got the t-shirt of getting my secrets exposed. It happens, okay? When you develop a lot of code, you can make that mistake, okay? It happens. But good hygiene is this, and then my use case is packet captures. So I chose here to read a couple of packet captures. One is the Mirai, the grandfather, like the speaker in the morning said, the grandfather of all IoT malware. We see variations of Mirai. I analyze a lot of IoT malware. We see it every day, every week. So it's here to stay. So I've analyzed a packet capture from Kaggle, actually, which is an open data collection website. Many data scientists use it. And then the benign packet capture is from Kaggle as well. It's just normal IoT behavior. So that's all there is to that. And then there will be a lot of pre-processing and all of these things. So the first thing I need to do is I have a packet capture that I've read with, OK, anybody knows what library we usually use to read packet captures or even create packet captures? You may have seen it in my imports. Very good. Excellent. So Scapy is the library. So then we have these objects that are not pandas data frames, so we want pretty little bears. So we have to write a little code. Again, I'm not going to say that this is the most efficient code, but I use KP, I extract IP layers, and this is where domain knowledge helps, okay? So if you know what you want to extract, you just write a quick function with if statements. Does this have TCP, UDP? That's all I want to analyze. I create a list of my data, and then I use this pretty pandas data frame, and now it's a data frame. So in order to avoid doing that and doing it faster, I've also saved my data into pickles, which are like text files for my data. So here is what it looks like at the end of the day, the packet capture. So you see familiar things that you may see with Wireshark. Timestamps, source IPs, destination IPs, and so forth. You see a lot of values that are missing, none values, yes, I said it right. And we will take care of that, or actually AI is going to take care of that. So here we go on the moment you were waiting for. Okay, so all we have to do now, if we want to be data scientists, and you can omit all the parts of my code that are traditional and just use the AI parts and adjust them to your own needs, is to have an API token or our own model, okay? But it's much easier for now to use OpenAI. So we need that API token and then the Pandas AI framework. And then we need to do one more conversion, unfortunately, convert our data to a smart data frame, because they have used this language, this library called LangChain, to break down your data, to chain it towards the GPT model. So we have to use another object. And then we can use one of their functions. Okay, so after we convert this pandas data frame that it was only a little bear to a smart data frame, which is a smart little bear, then we can use their functions. So clean data, I used to have to write, regular expressions, and I suck at that, and all of these painful things, and now I just can call a function. Okay, so you see the original data frame was 764,000 lines and some change, and now it's 197,000 lines, because all of the values, the none is a value. Then N-O-N-E, my accent doesn't help in the difference. So these are cleaned up, okay? So you can see that, it did a decent cleanup, and that I used an out-of-the-box function. I didn't even write the prompt, okay? But there's other ways that you can actually write the prompt. So then, again, the demo for the benign data, and we have less data. Let there be clean data without having to do garbage collection as I used to. Okay, so now that's something sometimes I want to do an experiment if I can have some interesting insights, or shrinking my data by extracting streams and not analyzing single packets. So using source IP, destination IP, source port, destination port. That was just to make my model faster. So you can use that function. It's not amazing, but I use streams from now on because it's less data. So what I want actually to insist is, now I still have a pandas data frame. Okay, it's not a smart data frame. It's just a cute little bear. But the power of these pandas, and I recommend that you check it out, is that I can have one-liners that can give me even more insights about the data. Single line of code, all the columns of my data. Single line of code, all the data types. So I can see that I don't have all numerical data, so I have to do something. So since I don't have all numerical data, I will use an IP function an IP library, actually, to convert the IPs to numeric so that I can finally have all numerical data. So I do this in here with the IP to numeric function. So here's the thing with pandas. They can be inefficient. So again, you have to forget your for loops and start using this apply function. This is unfortunate, and hopefully, eventually we will do all of this with prompting and not have to do this. So that's the thing. To apply a function now, I'm not doing a for loop through all the lines of my spreadsheet. I'm just using the function name as a lambda, and that's about it. So this is unfortunate, even though pandas is a great tool. And now you see that after I run these functions, I have all numerics in my data frame, so I can do more exploration. Okay, so I can get stats, because I cannot get stats if I have words. So stats, again, single line. If you retrieve something from this, is you don't have to be an algorithm wizard to be doing this data analysis. Okay, with your data frames and a single line of code, you can get descriptive statistics over here: count, mean, standard deviation. You can, with 4 lines of code, you can get a heat map of your statistics. So this is still not AI, so I'll breeze through it. And after that, actually, you can look at the relations of your data: source, destination, port, protocol, number of packets. This is a bunch of numbers, so I need to draw it. Okay, so this doesn't look as good. I'm going to make it smaller. Okay, so this one, a heat map, again, okay, even if you don't understand the math over here, the bigger, the brighter the color, the more the correlation. So I can say here that protocol has an interesting correlation with destination IP numeric. Okay, so this is what my correlation numbers found. Okay, so of course the diagonal is all very bright red, because the source port is completely correlated to the source port, the destination port is completely correlated to the destination port, and so forth. So these visuals can give you a story of the data, and you can see, the malicious data show a different heat map than the non-malicious data. So it can give you some really good insights just looking at pretty pictures. But I know that you're getting tired of these, so I'm going to breeze through the hypothesis testing and outliers, and I'm going to get to the AI. So all of these things that I've been doing with having to learn, having to read the documentation about pandas and understand how to use these functions and all that, I can do them with AI. I can interrogate my data. Now I'm using a little different version of the pandas AI, so that's why I have these 2 versions. Now I'm doing my own prompting, so I'm not using their out-of-the-box function. I'm doing my own prompting and asking the AI what are the top 5 source IPs, or what are the most popular destination ports. And actually, this was a recent question: which are the most rarely used ports within the range of, and do you want to do this for the malicious data? So this could take a while, and like I said, maybe I didn't sacrifice enough hair pulling. Okay, so Okay, so which are the most rarely used ones? So these are pure, oh, it did it really? It didn't say anything. Womp, womp, womp. Okay, so this one was 69, but this one was womp. So maybe we can use a different, maybe the stream. So at this point, okay, you are not using deterministic. So there's a caveat to that. Okay, you're not using a deterministic mathematical function from Python. You're using an AI, and so that may not be as good as you would like it to be. Okay, so did it answer? So actually, it did answer. So there we go. And it did answer with a table, actually, this time. So So definitely something that I use mostly as a black box right now, but I would like to dig into why it gave me only one answer in the previous one, and now it's giving me a whole table. So now here's the thing that blew my mind. You can actually use the AI to do graphs. Okay, that's not a pretty graph, but you didn't have to, again, go through all the documentation to make graphs. You can actually use the AI to make graphs. And actually, I had this brilliant idea to use one of those and do another graph live. And this is going to take an hour. This does take some time. Okay, so let's do a histogram with the malicious data. But it's worth it. I mean, it's time that you can sit, pretend to be compiling, playing a video game or something, instead of reading the documentation. So there. But I will say, look at the rest of my notebook, because I do have the standard ways. It did it faster than expected. So here, and it looks like a long tail. So that's pretty good. And there's some, okay, data scientists have spent a lot of time doing these. So there's a tons of libraries. Like, look at that. Okay, this is a nice exploration of all your data with a single line scheme. So I have a lot of those, more pretty packages, but this is not AI. So I'll skip through to the AI. So here, we're going to models. Okay, I am going to just show what models I used. Okay, I used 3 models over here because I'm doing supervised learning. I know that I have Mirai and some benign data. And so I use 3 different classifiers that are all supervised. Single lines of code, no glory over here, except you can explore these parameters. I used a lot of curves that you can look into, and they can help you evaluate your model, but I'm not going to get into those. I'm going to get to the AI classifier. Okay, so the AI classifier was a little womp, womp, womp for me compared to the other things that I could do with actual Python packages, because it's only working on words. So if you see here, I'm only choosing the payload from my packet captures. I'm feeding it the payload and labels. So it's going to look only at the payload and try to figure out whether there's malicious or non-malicious behavior. In this case, I'm using a completely different package. It's called Scikit LLM. Scikit is a very known package. And I can be brave and start running this, but it's going to take a while. So I'm going to show the results first. You see a little, again, okay, this is what a data scientist may not like. It's the fact that there's inconsistency. So GPT-3 is doing a little better now than GPT-4. How? Well, I'm giving it very little data, 100 of payloads, so, you know, it just happened. Here, GPT-3 is doing a little less good than GPT-4. So I'll start running this, and I'm going to stop. I think I have 10 minutes, right? Perfect. Okay, so I'm going to stop for questions. I also have to test you on some things. Some of you were very kind to answer things, so maybe I should be giving these. But yeah, I'll start running it. So caveat on that, if you start using GPT-4, so this is using the API for GPT-4, you do spend a little more money. So I spent like $5 to prepare for this conference. It's not too bad. But if you're a college student, maybe you will need to watch that or something like that. Okay, so any questions or any observations? Yeah. So the question is, how much confidence can I have in the results that I'm getting from the LLM when I don't see exactly the process? Is this, am I rephrasing this correct? So I don't have too much confidence, so I trust it, but I verify it. So the scatter plot that I did, and because I had to go through the process of learning how to do this, I would verify it. However, there are some things that you can verify without being a data scientist, right? If you ask it to give you the top ports, you can do this with a spreadsheet. You can export your packet capture to a spreadsheet and verify it. It answers pretty well because they're feeding it properly, the data. For simple questions, the answers are pretty good. For more complicated questions, this is the most complicated question that I'm asking it, to classify things. So the deterministic stuff, like make a graph, pick the top 10, or do some summary statistics, it's pretty good because it's simple logic that it's being taught to learn. This stuff that is more a model, trying to make a model inside it to recognize malicious pickup versus non-malicious, that I don't trust at all. For now, I would need to look. I haven't dissected the code of the zero-shot classifier. I know what zero-shot prompts are or few-shot prompts, but yeah, this is hocus pocus right now. So that I don't recommend. I do recommend Pandas AI for interrogating your data because it's pretty deterministic and it's doing a good job, and you don't have to write much code for it. You just can ask really good questions, and yeah, so thank you for the question. Yeah.
So how does Pandas AI handle the parametric versus the non-parametric data sets? Because normally you're looking at the PCAP, it's huge, right? Does it handle the non-parametric aspect of some of this data analysis well, or do you know on that?
So the question is, how does Pandas AI handle parametric from non-parametric data sets, and especially the size, correct? So I have to say that I have tried to experiment with the original packet captures in the beginning, and the time was unbearably slow because, again, I'm going to an API call. So when I'm uploading 700,000 rows compared to 200,000 rows, there's a huge difference. With that, when you say parametric, do you mean like parameters of a model, hyperparameters, or do you mean like just the features of my data set and the volume? Is this what you mean more? So the performance is not good, okay? So I wouldn't wait for that long. However, in my kind of day-to-day, in my day-to-day, I'm training my own model right now. So you can train, so now you can train a model in only packet captures, let's say. Okay, so you decide to make a language model that understands how to read packet captures. The only thing you need to do is learn how to teach it, okay? So it's not as easy as I'm presenting it, but if you have tons of packet captures, you can definitely do that. So with that being said, if I had a local model, I think because of the API calls that I do, I'm getting throttled. There's a lot of things that they're doing also. I have a paid account, but it's not an enterprise account. I think that a local model would work much better with that. So I recommend that you get one of these free open source models that are small and train your own. I mean, it's very doable, actually. Again, you need good domain knowledge to train a model. I may do a talk next year on how to train a model as a security engineer. All you need is really good data. So this is not even as much math, but yeah, the good data is tough to get.